Welcome back. Here we are. It is Unit 3-2, Common Binomials. We're going to be here working in Chapter 8 of our textbook. In our pacing, it's going to be Unit 3, Lesson 2, Common Binomials. All right, let's take a look. Here's another math career for you, a computational biologist. That's quite a mouthful of words there. A computational biologist applies the techniques of computer science, applied mathematics, and statistics to address biological problems. Lots of math and science here and biology. So, this has to do with life science and so on. If that's something that intrigues you a little bit or something you're strong at or interested in, this might be a career you could think about. There's your salaries there at the bottom, and you can see a nice generous salary there at the high end. And then, of course, you have your math that's needed over here. And if you come across and you want to know what any one of those are, I might be able to explain a little bit of those, or you could just ask Mr. Google. He probably knows better than I anyway. All right, here's our standard, 11.0. And today we're going to learn to factor common binomials. Common binomials. So again, this is a review from yesterday. Greatest common factor. We saw that yesterday. To factor something means to break it up. And a factor is just something that pieces have in common. Okay. So reminder from yesterday, let's factor out common binomials. 4x minus 6. What do both the 4x and the negative 6 have in common? Well, we decided yesterday that they had a 2 in common, right? So if we factor out a 2, then we write down what's left, and this is called, this is a factored expression now, because the expression is broken up into its two factors. 2 times the quantity 2x minus 3. All right, take a look at this one. Just watch this. No pens, no pencils. This is going to look a little different here. Let's go ahead and read this. You've got 2, then you got the quantity x minus 3. Those are factors that are multiplied, plus x times the quantity x minus 3. So when you look at those two terms there, what do you notice they both have in common? Well, they both have an x minus 3 inside parentheses. So I underline those for you, and if we factor out what is underlined, well, let's go ahead and pull that out to the front, and what's going to be left behind? Well, if we take this and we extract the, the x minus 3, grab my pencil here, if we remove this x minus 3, just pretend it's not there. Let's just kind of write over it. Let's say that we pull that out front. What's left behind here? Well, it looks like we've got a 2 and a positive x. And actually, that's exactly what our answer is going to look like here in just a second. Because, look what happens. When you pull out that x minus 3, you end up with times the quantity 2 plus x. Isn't that what was left over when we took the x minus 3 away? All right. How about we do this one together? Go ahead and add this to your notes. Factor out common binomials. You've got 2y, and then times the quantity y plus 4, plus 5 times the quantity y plus 4. So we notice here that y plus 4 is a common factor in both of these terms. Let's go ahead and pull that y plus 4 out to the front. And again, if we just physically did this, we took this here, maybe I'll change colors here. What if we eliminate the y plus 4, eliminate the y plus 4, what's left? Well, what's left is 2y plus 5. So we're kind of pulling that out, we're seeing what's left behind essentially. And what's left behind here is this piece right here. Y plus 4 in parentheses times the quantity 2y plus 5. Okay? And that is your factoring common binomials right there. Try this one on your own here. What do you think? X times x squared plus 4 plus the quantity x squared plus 4. Alright, so something that looks a little different here, and I guess the main reason it looks different is this has a coefficient of x, but what's this coefficient here? What's the number hiding in front? Well, remember that if there's nothing stated, we always know there's a 1 there. Okay? So if we went ahead and just did what we know how to do, we're going to cross out or just ignore these two. We're going to go ahead and factor these guys out. So this comes out to the front, and then we're going to end up with what's left over. So let's see, x squared plus 4 comes out to the front, and what did we say this coefficient was here? It was but the number 1. So you're left with quantity x squared plus 4 multiplied by the quantity x plus 1. And this is your factored form right there. All right, how about this one? Go ahead and give this one a try. Very similar to the previous one. If you want to press pause and jot it down real fast and start it up again, I'll wait a second here. And of course what we can see is the common factors are going to be x minus 3, and then we write down what's remaining, and what's left behind is 1 plus x. And of course you can rewrite that as x plus 1 if you'd like, because remember addition is commutative, so you could switch it if you'd like to. I just left it in the order it was given to me, a 1 and a plus x. Alright, how about this one? 2b times the quantity b plus 4 plus 5 times the quantity 4 plus b. Now remember what we just talked about with the addition being commutative. What does it mean to be commutative? Well, it means they can switch the order, correct? So what do these two have in common? Well, they both have b plus 4. It just happens to be that the one on the right is just turned around, saying 4 plus b. So they'll kind of throw those at you a little bit and see if you're familiar with the foundation of understanding arithmetic, that you can switch addition. So b plus 4 gets pulled out, and you're left with 2b plus 5 left behind there. So that's your factored form right there. Okay, now take a look at this one. Factor out common binomials. This one's going to be a little trickier, and you'll see only a couple of these during our time together. You've got 2y times the quantity y minus 4 plus 5 times the quantity 4 minus y. Now what you'll notice, of course, is these two guys here are really close to being the same. y minus 4 and 4 minus y. But unlike addition, subtraction cannot be reversed automatically. So what are we going to do about this? It sure would be nice if this was y minus 4. Then things would be pretty easy to work with. So let's see if we can do something here. And I'll show you what we can do. What we can do is this. We're going to realize that this binomial cannot be turned around as it is. So here's what we'll do. We're going to multiply the whole piece there by -1. The whole second term by -1. What that's going to do is it's going to reverse the sign. So when you multiply by -1, remember that everything here gets reversed. So the positive 5 becomes a -5, and the positive 4 becomes -4, and the negative y becomes positive y. And that may look like cheating at first, and I'll show you how it's going to be fair here in just a second. If we look back at our first term over here on the left, isn't this positive y and -4? And if we look back on the right now, isn't this now positive y and -4? So let's reverse these and see if we can turn it around, because now it can be turned around. So now we've got y minus 4, y minus 4, but now look what happened to our coefficient here. It went from positive 5 to -5. All right. Now, just to prove to you that what we did was not something underhanded, if you were to go back to the original problem and we distributed this, what is positive 5 times 4? Wasn't that 20? I'm going to put a little 20 up here. And what's 5 times -y? Well, that's -5y. Okay, so this is a 20 minus 5y. Let's look here at our end result. What's -5 times y? Well, that's -5y. And what's -5 times -4? Well, isn't that positive 20? So really, we have a positive 20 here and a positive 20 here. We have a -5y here and a -5y here. So what we've done is nothing underhanded. We've just manipulated the problem using a little bit of logic there to help our situation out, so we can actually do what they asked us to do, which was factor. So let's go ahead and factor out the y minus 4, and what's left behind? 2y minus 5. And there's your factored form right there. So yeah, kind of a tricky one there, which you'll come across on occasion, but not very often. Alright, now remember, Swiper will never take more from one group than the other, but at times the groups are too big for Swiper, so he breaks them down into smaller groups. And this will be pretty obvious, especially our textbook is pretty friendly with this. The older one we used to work with back in the day was not very friendly at all, but this one, they play pretty nicely here. And here's an example for you. You've got now a polynomial with 4 terms, 4x cubed, positive 6x squared, positive 10x, positive 15. And what we can see here is that this is going to be too large really to tackle, and there's really nothing we can take from everything. These guys have x's, but he doesn't. These guys are even, these 3 are even, but 15 is odd, and so on. Okay. So what can we do? Let's go ahead and break it into 2 smaller groups. So maybe we could group this up into 4x cubed plus 6x squared, and we can view that as a group, and then we can view 10x plus 15 as a group. So let's tackle the first one here first. What do these two have in common? Well, they're both even, and we can take out an x squared. So you're looking at 2x squared there, which leaves you with 2x plus 3. So let's just write that down and forget about it for a second. Now let's look over here. What's 10x plus 15? What do these two have in common? Well, do you say a 5? If they have a positive 5 in common, what's left after you remove the 5? 2x plus 3. And of course, that's what I mean by them playing nice and friendly here, because now you can quickly see that they both have a common factor of 2x plus 3. So now we go back to what we know how to do, factor out the 2x plus 3, and you're left with 2x squared plus 5. Alright, so a little bit to do there, but we just take, whenever you see something with 4 pieces, let's try to break it into 2 groups of 2 and see what happens. Alright, how about this one? 6x cubed plus 4x squared plus 3x plus 2. Right off the bat, there's nothing we can remove from everything, so we're going to go ahead and break it into 2 smaller groups. Okay? So how about that and that? Now you might look at the first piece here and say, yeah, I see x's and even numbers, but I'm not so sure about this piece. What the heck? 3x plus 2, there's nothing there. Well, let's see what happens. So, take the 2x squared out of here. If you divide this by 2x squared, what would you end up with? What's 6 divided by 2? Well, that's 3. And what's x cubed? And if you remove 2 of the x's, you're left with x to the first. So, look at that. You end up with 2x squared times the quantity 3x plus 2. And what is this guy sitting right here? Well, isn't that just 3x plus 2? So since they have no common factors, just rewrite it. Okay? And now what do we remember about the coefficient? Well, this coefficient is 2x squared. But what's this coefficient here? That coefficient is the number 1. Okay? So let's factor them out. Let's see what happens. We take out a 3x plus 2, and what do we write down as the second factor here? 2x squared plus 1. Okay? Very good. Alright, and that's it for Unit 3-2, and there's your information if you want to see some more work on this in a little different light. And make sure you have a question for us, alright? Okay then, we'll talk to you soon.